everybody. This is Larry. This is me in Cappadocia, in Turkey, on Saturday, August 27th. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 363 maximum rectangle no larger than K. Hope you enjoyed that video that I have in the intro. I do it when I travel and hit. Oh, excuse me. Yeah, follow me on Instagram if you want to see stuff like that. More handles Larry somewhere. You could. There's a link in the description below as well. Okay, let's get started on today's thing. It's so here in Turkey, this is in the morning for me. Where in New York, when I do them, it's at night. So at night, I'm just more woke up, I guess. So we'll see how that goes because I'm feeling a little sluggish. Okay, so given an m by n matrix and an integer k, return the maximum of the rectangle in the matrix such that the sum is no larger than k. I guess that's literally the name of the title. So it's guaranteed that there'll be a rectangle of sum no larger than k, and there's negative numbers. Okay, what is n? N is 100. So so okay. Well, I'm just thinking about the different scenarios in my head. The big one being, can I do an n cube time, right? Or 100 cube rather, not n cube per se. So what would that look like? So if you choose every two corners, that's going to be n 100 to the fourth, right? Because there are r times c number of right corners to the right, and then r times c corners to the left, and that's going to be too slow. 100 to the fourth is 100 to the second is 10,000. So then that it's going to be like 100 million, right? So that's too slow. So we have to figure out how to optimize it a little bit more, and that's assuming that you have. If you do prefix sum, you can do the sum of everything inside an O of 1, right? So that'll be it. So we have an n to the fourth way. Can we do it in better than n to the fourth? I'll make my screen a little brighter. Can I use k in any way? Well, I guess the way that we can think about k is some sort of sliding window, I suppose. I mean, that's my guess, because I think if we can solve it more generically, then I don't know, like if we solve it more generically, then well, can we solve it more generically? Because there's the technique where we can do for every two rows, and then we can do the 1D version, and the 1D version would be okay, yeah, let's think about that for a second, right? What is the 1D version? 1D version is giving a 1D array. What is the rectangle, what is the sub-array that is no larger than k? And there, I guess we can do binary search on all the prefix sums, and just get the bigger number. Okay, and so for everything to the right, we do a binary search. So that's going to be let's see, for every so n log n. So that's going. So we have r that's going to be r squared c log n, or log r, or something like that, or log c. Is that too slow? 100 cube is 1 million. So log n is going to be like less than 10. So maybe that's fast enough. What's that? I just set this up a little bit better so that the lighting is a little bit better. But Okay, so that's my thing right now. But I think the hard part is just trying to think what is fast enough, right? Because in that case, then because in that case, it's just kind of a guessing game of whether Leetcode is just fast enough for that, and I'm just trying to think whether R square times C log C or whatever is fast enough. And I'm just trying to also think where if there is this sliding window. I guess not really. Or like if we keep like like we wouldn't say binary search, but given the window looks like this, you move one to the right, and then in the left you you move one and one. But you can't really do that because of the negative. So then you could keep on it because of the negatives. Maybe even if it wasn't the negatives. Well, if it wasn't for the negatives, then I guess you could do repeated doubling or something. So I mean that's still binary search. So I guess that's gonna be the same idea, except for just a little bit different. So yeah, let's see if it's either that or maybe we use C++, so we'll see. But okay, let's okay, let's do it then. Yeah, okay. Let's try to do the math, and then we'll see if the R squared times C log C works. And also the follow-up is just if the number was much larger than the whatever, then you just swap and then rotate the matrix or something, right? But yeah, let's try it. Yeah, okay. So that means that for x1 in range of x2 in range from x1. Yeah, okay. Oh, right. Okay. And in that case, yeah, we just have, and this is now we're converting to 1D, right? So then for y in range of c, so then here we want the now we want, sorry friends, yeah, Herman, you're trying to follow. I do usually draw this out, but I'm I don't have I'm in Turkey, so I don't have my drawing utensils usually. But the idea here is now the idea here now is that given x1, x2, now we compressed it to a 1D problem, and during the 1D, this is just a regular max subarray with no larger than k, right? So that's basically the idea. And then here we want the sum of something like the matrix of of y plus dot 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 plus matrix x2 of y, right? So of course this is going to be a for loop, but we're already slow, so let's compress this with over 1 by doing some sort of prefix sum. But here we just do the x component or the row component. Yeah. I'm just used to writing it this way, but fine, right? And here I guess we just add the columns. Something like that. And this will get negative, so then we just add 1. Yeah, I think this is okay. And then here then just becomes a prefix of x2 of y, so that contains up to x2 minus minus x, something like that, I think. Okay, and then and then here we also want to do sort of this. So now we have a sorted list, and then in fact maybe we'll use sorted set. I actually don't know if sorted set or sorted list is faster, to be honest. But we'll use sorted set because it makes sense here. At the very end we add the current, but before that we do a binary search. So then that means that we have the current number plus some previous number is less than or greater than k is what we're looking for. So then we minus current on both sides. So then the previous number we want to binary search is this number. So okay, so k minus current, so SL that bisect left. Is that then what are we looking for? So we have this, but we want to get, let's see, previous is less than or equal to, so we want a number that is let me make sure I'm getting this right because I'm getting confused. So at this, we want the max this, right? The max part is the part I'm getting a little confused about. So then, why is this so weird? Okay. So I think this is right-ish. So we want to max this. Right, so we binary search for it. Okay. So SO of index if maybe I got this right wrong, but also I need that too. I guess there's always an answer, so if this is the case, then pass is equal to and pass is less than SL of index. This is the previous plus current. Something like that. All right, let's give it a run just for typos. I'm getting hungry. That's okay. Waking up. That's why I'm looking at it. Okay, this looks okay. Okay, moment of truth. We'll see if this is fast enough. I don't know. Also know if this is right enough, because this is just like 2D array. This is a 2-row and 1-row column. So, yeah, I got it right last time. Very easy off by ones as well, the way that I did this. So that's why I'm a little bit sketch, and also time limit potential. Wasn't that the? Well, I mean, he could have negative infinity, which is wrong, but so I'm. Does it tell you the timing? I'm just wondering. Okay, I don't know how long it took. Okay, because that's the part I worry about. This part I can fix. How can I even debug it? I quite sorted this anyway, but it's just this with 0. I don't know how this helps, or the way that I did it, but okay. Okay, so okay. Maybe we just got cut off. So 0. So we have sum of 2. We binary search. There's no answer because this one, there's guaranteed one answer. So 4, nope. 3. The sum is 3. We find the 4, right? So it's 0 to, yeah, so for 3, let's see, -1, so we have 3, well, no, negative is 0 minus 3, so we search for -3, we find the 4. Is that not right? Oh, index is -1. Is that it? Because we just want a number that's bigger, right? So okay, so okay. Yeah. I actually thought about this, but I didn't think. Maybe my defaults were wrong, because usually my defaults are a little bit better, that's why. Why is that? So that didn't help. What am I doing? No, this shouldn't be -1, right? Wait. That's what I need to do. So I binary search for -3, and it returns -1. Because we want the number that is did I do the math wrong? Let's see. So we have -1, the current sum is 3. Right? So in order to get a 0 or more, I need a partial sum that is, so 3 plus negative 3 plus -3 is fine, but instead we don't find it. Did I get the thing? Did I add it to say? How is that right for so many cases though? If I got this one wrong, this part I wasn't thinking about it, to be honest. Okay, I think I messed up on the prefix sum, that's why. Basically, I just lazy wrote previous plus current is less than k, but that's not prefix sum. That's just, I think I was thinking of it, the other lookup problem. What we want is actually prefix sum. Yeah, because this is so current is the total sum up to here. So then you have to find binary search what to subtract from. So actually it should be, I'm such a silly boy. So it should be current minus previous. So then we minus k on both sides. Okay, so that's, I thought this looked at a sketch, but okay, fine. And then now, okay, so that's why. So maybe, I don't know if that would have been right, but now to fix this, because now it's current minus this previous thing, right? To get the prefix sum. Sloppy. Okay. Did I get that right? Because now why does it have 2? Let me fix that one first. I don't know why we're on the other ones, but this one should be different. So we have the current sum is, oh well, this one we're looking for the wrong thing, or outdated thing. Run it real quick. Okay, so it's 0. So S2, prefix sum 4, and then 3. So then we're searching for 3. Do we not find 4? Okay, so here we have the 4. We search for a 4. but we get our bounce. And then that gives us 2, right? Did I binary search the wrong way? Maybe my other way was happened to be right because we want. So for 4, we definitely want a number that's bigger than it. I want this because I think okay. I think before it was from another thing. Excuse me. Ah, jeez. I think once I change the formula, things are a little bit more weird. Let's see if this is right. I hope so, because I want to get breakfast and go hiking. And I spent about half an hour on this already, which is a little sad. Okay, wow. 9.7 seconds is pretty slow. There were a couple of optimization I thought I could make. Excuse me. How did I do it last time? Or did it just add more test cases? I guess I did do the same. Oh my god. Clearly I'm allergic to something. It's 8:30 a.m. Maybe I'm allergic to waking up early. This is a half an hour video, which is kind of sad, but okay. I mean, I guess I did it the same way. I don't know if that binary or like sorted list versus sorted set is the reason. Let's take a look. Ah, jeez. Morning Ghiblis. But yeah, maybe this will time out. I don't know. That's still very. Oh well, it is faster. So next, I guess in the future, I know. So just being Leetcode, it might just be Leetcode being weird. So yeah, so the complexity of this is going to be R square from these 2 loops, and then here this is just C log C. So all of R squares C log C time space is going to be, this is n or R times C. Yeah, space. That's all I have for this one. Let me know what you think. I know my explanation isn't as good, but check out my video from last year. I'm getting out of here. Allergies and everything. I don't know what's going on, but I need to get out of here. Yeah. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, because wow, this took a while, even though I knew what to do or the idea. Anyway, good luck on your contest if that's coming up, and I'll see you soon. Bye bye.